let's have a look at permutations next. Permutations are arrangements of objects where the order matters. So it's basically what we've been doing all along with the fundamental counting principle with no repetitions, but it's just written differently. So for example, if you have the word, well, the one we did last was the word Yukon. If we want to find out the number of ways that we can arrange these letters using all of them, we do 5 times 4 times 3 times 2 times 1. If we only want to use 3 of these letters at a time, how we would find that out is 5 times 4 times 3. So the formula for permutations does just this, 5 times 4 times 3. You're taking n objects, so in this example we have 5 total objects, and we're taking them r at a time. So that's what this formula tells us to do. If we have n total objects to choose from, and we're taking them r at a time, we do this formula. So on your calculator you have a function that'll do this formula for you. So the function on your calculator, you hit math, go to the left one, and hit 2. So with our Yukon example, we're taking 5 letters and we're picking them 3 at a time, as just like we did here. So with our Yukon example from before, we have 5 letters to pick from total. Our n is 5, and if we take them 3 at a time, this is the situation that we have. If we have 5 total objects, and we're picking them n at a time, 2, and we're picking them 3 at a time, we get 60. So this should be the same as 5 times 4 times 3. You get the same answer. So here's an example. How many ways can you arrange the letters in the word Columbia? The arrangements need to start and end with a vowel. So there are 1, 2, 3, 4 different vowels, and 1, 2, 3, 4, 5, 6, 7, 8 different letters. 4, 5, 6, 7, 8 letters. You need to start and end with a vowel. So there needs to be a vowel in this position, and also in this position. If we have 4 letters to choose from, we can place in the first spot. Once this vowel is chosen, there's only 3 remaining vowels that I can put here. Once we've chosen these 2 criteria, so the word needs to start and end with a vowel, now there's only 6 letters left to choose from for that spot. But once this letter is chosen, there's only 5 left, then 4, then 3, then 2, then 1. So you can just write this as 6 picking 6. And once you put this into your calculator, you end up getting 8,640. So that's the number of ways that you can arrange Columbia, and it starts and ends with a vowel. So here's another example. We have n plus 1, picking 2 at a time equals 72. So for this question, we would have to find out what n is. So there's a number of ways you can approach this problem. One way is just trial and error, and you can use your calculator for this. So you can find out some number picking 2 at a time will give us 72. Try maybe 8, and then pick 2 at a time, 56. So we need maybe a bigger number. Try 9. So 9 picking 2 at a time, that gives us 72. So this number would have to be a 9. Picking 2 gives 72. So we need to subtract 1 from the 9 in order to get what n is. So it would be 8 plus 1, pick 2, and give us 72. The other way that we can do this is by writing out the formula. So where we have n plus 1 picking 2 at a time, we can use this part of the formula and see what that gets us. So everywhere where we have an n in the formula, we need to substitute in an n plus 1. We have n plus 1 factorial, and then anywhere we see an n in this formula, we need to put in an n plus 1. So n plus 1 there. And then for r, we have a 2, so minus 2 will go on the bottom here. It's factorial, it's 72. So next thing, we can simplify this a bit. So we have n plus 1 factorial over n plus 1 minus 2 is the same as n minus 1, because negative 2 plus 1 is minus 1. So this gives us 72. Now our strategy here from before, we need to expand bigger term in the fraction when we're dealing with fractions and factorials combined. So we keep expanding the bigger term, plus 1 and n minus 1, until we see a cancellation. So we can stop at n minus 1 because there is an n minus 1 in the bottom that we can cancel out with. So n minus 1 factorial divided by itself is just 1. This is equal to 72. So this will give us n squared plus n equals 72. So you can just write that as n squared plus n minus 72 is 0. So we need two things that multiply to give negative 72 and add to give 1. That turns out to be minus 8 and positive 9. So solutions to this will be positive 8 and negative 9. We need to discard the negative solution because we can't take the factorial of the negative. So our answer is n equals 8, which is the same as what we got from trial and error using our calculator. Here's another example. There are 9 digits in a social insurance number. If a SIN begins with a 6, how many numbers are possible? So there are 9 digits total. So 2, 3, 4, 5, 6, 7, 8, 9. So just use the fundamental counting principle. If it starts with a 6, there's only one decision that we can make for the first one, and this has to be a 6. For the next number, we can have anything 1 to 9, including 0, so there's 10 possibilities for the next position. And then if we can repeat digits in a social insurance number, we have 10 available for the next decision. 10, 10, 10. 10s for all of these positions. So when you multiply all of these together, this will give you 100 million. That's the number of social insurance numbers that are possible that start with a 6.